Hello and welcome to Data Analysis with Python 0 to Pandas. This is a free certification course. You can register to get certified at 0topandas.com. My name is Aakash and I will be your instructor for this course. Today we are going to continue working on the basics of Python. So let's get started. Where you should go is the course page 0topandas.com. So today we are doing lesson 2. So let's open up lesson 2. So lesson 2 page, you can open up conditional statements and loops. Once again, I'm just going to click the run button to run this on Binder. So here we go. Now we have the new notebook. I'm going to do kernel restart and clear output. And I am going to hide the toolbar. And we're ready to get started. So one of the really powerful features of programming languages is branching, and branching is the ability to make decisions and execute a different set of statements based on whether a condition is true. And what does that mean? I want to show you with an example. So here, the simplest way to introduce a branch in your code is to use the if statement, and which is written like this. So you say if, and then you put a condition after the if, and then you put in a colon. So this is to indicate that there is something below it. And now you can then put in a bunch of statements, right? And all of these statements, you have to give them a little bit of a space. So just give them 4 characters of space before the statement. So here there are 4 characters before statement, and then we have the statement itself. Then we have another statement, and all of these statements which are indented. So these 4 characters of space before a statement are called indentation. So all of these statements that are indented belong to the block, belong to an if block. And these statements get executed only when this condition is true. Okay, so let's look at an example of that. So here I have a number, and this number has the value 34. And now I'm writing an if statement followed by a block of code. So here I'm saying if a number which is 34, and this is the modulus operator which returns the remainder. So the remainder when 34 is divided by 2, so which will be 0 because 34 is even. If that remainder equals 0, so this entire condition, this entire expression returns true. So since this expression is true, then these statements get executed. So the statement we are inside an if block, and the statement print the given number, which is 34, is even. And notice that we are using string formatting here. So if I execute this, you will see that these statements get executed. Very simple, but a very powerful idea, and you will be doing this a lot. This is the bread and butter of programming, really, branching and looping. Let's try another example here. Now we have 33, and then with 33 we are once again checking if this condition is true. And if this condition is true, then we are going to try and print something. But you can see here nothing gets printed because this condition does not hold true. So that is basically the if statement. And what you might want though is you might want to do one thing if the condition is true, and you might want to do another thing if the condition is false. And that is where the else statement comes into picture. So what you can do is you can have a if statement, and you can have a block of code after the if statement, and then you can write else and give a colon and have another block of code. So if the condition holds true, then the first set of statements is executed. And if the condition is false, then the second set of statements is executed. Okay, so let's check it out here. So we have a number, and we say that if a number divided by 2 leaves a remainder of 0, then we say that it is odd. Otherwise we say that it is even. So here, since 34 is even, this gets printed. And then similarly, since 33 is odd, the second statement that the number is odd gets printed. Here is another example. So you can build these conditions in any way. So it does not just have to be arithmetic. Here is another example. I have a tuple, the 3 musketeers, and then I have a candidate. So what we do is we check whether a candidate is in the tuple. And that makes Python is so readable that you can just read this and understand what's going on here. So if a candidate in the 3 musketeers, then print that the candidate is a musketeer, otherwise print that the candidate is not. All right. So you can build these conditions and combine them in all sorts of complex ways, and that gives you a lot of power. Now, one other statement, which is, you may or may not use this a lot, but there is an elif statement that you can use. So when you want to check not just one condition, but a series of conditions, you can use the elif statement. So I'll just show you with an example what it does very quickly. So what we do is here is we say that if today is Sunday, then we print something about Sunday. Else, so else if, so elif is short for else if. So if this condition fails, then we check this condition and print something. And if that condition fails, then we check this condition. So as conditions keep failing, we keep checking the next condition. But if at any point a condition becomes true, so for instance, at today equals Wednesday, the condition becomes true, then we simply execute the code inside that block, and then we ignore all of these. All right. So that is the elif statement. Keep checking conditions until the condition is true. When the condition is true, execute the statements inside that block and then ignore the rest. Okay. And there are a few details here about elif and how it is different from simply using a bunch of chained if statements. So I will leave that for you as an exercise. So here we have tried the same thing with if elif, and then we've tried the same thing with just a bunch of if statements. So I'll let you try that out. And finally, you can use if, elif, and else together. So here I have the number 49. So what we do is we try to check if it is divisible by 2, and then we print it is divisible by 2. We check if it is divisible by 3, and we print that. We check if it is divisible by 5, and we print that. If none of these conditions hold true, then we go into the else block. So you can do a chain of if, elif, and else statements. Okay. And then finally, what you can also do, as I've mentioned before, is within an if statement, you can take this number and you can have a check on that number, and then you can do an and. So you can combine two conditions. So you have a number divisible by remainder with 3 equals 0, and a number remainder with 5 equals 0. And then only if both these conditions are true, you are going to go and execute this print statement that the number is divisible by 3 and 5. Okay. So that is the if else statement. Now, one other thing is that these conditions do not necessarily have to be conditions. In fact, they can be any value, and they can be any value in Python. For instance, it can be a string, it can be a dictionary, it can be none, it can be a number. And what happens is that Python automatically, whenever you put in a value that is not a Boolean, Python automatically calls the bool function on that value. And we've discussed this the last time in the last lecture, so you can look it up there. When you call the bool function, empty values like 0 or the empty string or empty dictionary or empty list get converted to false, and all other values get converted to true. So there are a certain set of falsy values, and there are a bunch of true values. Okay. And this is pretty useful because if you want to do a certain operation only if a particular list is not empty, then you can simply say if my list, and if my list is true, then you print something, else you print something else. So this is a very simple way to just check whether something is empty or not. And then again, a very minor thing, and you can try this out, is that you can have if statements inside if statements. So here is an if block. So we are checking if a number is divisible by 2 or not. And then inside the block, we have another if statement where we check whether the number is also divisible by 3 or not. And then what you have to do is this if statement itself has to be indented, and then the block inside it will require 2 levels of indentation because it is indented from an if statement which is already indented by 4 spaces. Okay. So check this out, try this out. First read this out line by line and try to predict what will happen as you put in a number here, which path it will follow. And as you change the number, try to see if you can get all of these print statements to show up in different cases. Okay. Now, one small piece of advice here is avoid nesting statements, if statements wherever possible. So if inside if is very confusing. So the maximum you should go is maybe 1 level of nesting, and try to keep your code as simple to understand as possible. Okay. So that is the if. Those are all the variations of the if statement. And then there is also something called a shorthand if expression. This is not something that we are going to cover in the lecture, but again, this is here in the notebook. So if you're going through the notebook, you can try this out. essentially what it offers is it offers a way to put the entire if, condition, statement, else statement, all of that into a single line, especially when you want to calculate a new value out of the if statement. Okay, so I will skip ahead for now. So I'm just going to save my notebook here, because this is something that you should just do from time to time. Keep saving your notebooks. So here I just take my API key and paste it in here, and that uploads the notebook to Jovian. Okay, we've gotten a lot of comments about people losing their work on Binder because they left the tab open for a long time or left their computer for a while. So just keep running jovian.commit from time to time on Binder so that you do not have to deal with that problem. Okay. All right. So now we've looked at conditions. The next thing that we're going to look at is iteration. And iteration is an extension of condition, or an extension of branching in a sense. So what it allows you to do is it allows you to run one statement or a set of statements multiple times. So we have something called the while loop in Python, which works like this. So you say while, and then you put in a condition, and then as long as that condition is true, so let's say you're checking the value of a variable, whether it's even or not, as long as that condition is true, the statements inside the while loop keep executing over and over again. And what you might normally do is that within one of these statements, you might change a variable, which might later cause the condition to become false. Okay, and that is when the while loop will end and we will continue with the execution of the program as normal. So let's take an example. You might be familiar with the concept of factorials. So what we will do is we will try to, the factorial of the number n is simply the product of all the numbers from 1 to n. So the factorial of 10 is 1, 2, 3, 4, 5, 6, all the way up to 10 multiplied, and so on. So we will write a while loop to calculate the factorial of the number, or a factorial of the number 100. Okay, and so the way we're going to do this, we are going to create a variable called result. This is what will get back the final result of the factorial. And then we are going to create a variable called I, which is, you can call it index, or you can call it like a counter. So I has the value 1, and then we create a while loop. So we say while I is less than or equal to 100. So initially, since I is 1, this condition is going to be true. So then these statements are going to get executed. So first we do result equals result times I. So since I is 1 right now, then result will continue to remain 1. And then we do I equals I plus 1. So I plus 1 is 2. So now we change the value of the variable I to I plus 1, which is 2. So now I has the value 2. So now we come back here. The statement, the condition is executed again. The condition is currently still true. So then we multiply the result with 2. So the result becomes 2. And then I now becomes 3. Then we check the condition again. And then we multiply result by 3. So result becomes 1 times 2 times 3. And 1 into 2 into 3. And then we have I gets increased to 4. And now you get the idea, right? We keep repeating this over and over till this condition becomes false. That is, till I becomes 101. And when I becomes 101, at that point, this condition is false. So at that point, we break out of this loop. So it's called breaking out of the loop. And then we can go on executing the program with the statements that follow it. Okay. So let's run this. So you can see we ran this and it took hardly an instant, and it gave us the factorial of 100. And you can check whether this is actually the factorial if you want to. You can look it up online. But that's basically how this code works. And the real powerful thing here is that just with these 4-5 lines of code, we have been able to calculate the factorial of 100. But if you want to go from 100 to 1000 or even 100,000, all we have to do is change this. And that is what makes computers really powerful, that with a few lines of code and with their real speed of arithmetic operations, they can compute a lot of different things very quickly. So here we have, for instance, here we are trying to calculate the factorial of 1000, and I've added this special command called %time. So this %time is simply going to tell us how long it took to execute this cell. So yeah, I run this cell and I get back 1000 factorial, which is this huge number pretty huge. And it took only a total of 2 milliseconds, which is like a thousandth of a second almost, pretty much. So that's why loops are a really powerful thing in programming, because they let you process a lot of data really quickly with a few lines of code. So now here are some exercises that you can try out with the while loop. So with the while loop, here is a pattern that I've printed out. So I've just printed out this nice pattern using just asterisk characters. So that takes a couple of while loops to print this out. So try and see if you can understand what's going on here. See if you can make sense of this code, and then use that to maybe create a couple more patterns. So here is one more pattern. This is the mirror image of that pattern. And then here is like a diamond pattern or a rhombus, putting these two together. So try and see if you can write the code for these, especially this one. It can be a little bit tricky. So if you can figure this out, then you have really gotten a good hang of loops and iteration in Python. Okay. One other thing that you might want to keep track of is that sometimes you may make a mistake while writing your code. So here I am calculating factorial, but within my while loop, I may have forgotten to increment I. Okay. So when this happens, when you forget to increment, what happens is this condition remains true forever because I is not changing. And when you run this cell, now it's just going to keep on running continuously forever, and you will not be able to execute any other code in the notebook. So this is called an infinite loop because the program is stuck in the loop forever. And the way to come out of this is to interrupt this execution or to stop this execution. And there are a couple of ways to do that. So you can go kernel interrupt, and that's going to interrupt the loop, and then you can make the change and rerun the cell. And then the other option, and by the way, here is another example. Here what I've done is I am incrementing I. So again, we are calculating factorial, and I am incrementing I, but I put in the wrong condition here. So this condition, again, I can keep on going to 1 million or 2 million, but I greater than 0 will always continue to hold true. So this goes into an infinite loop as well. So the other way to stop it is if you have the toolbar open, next to the run button, you have a stop or an interrupt button. So you can simply press the interrupt button, and that is going to stop the execution. So those are the two ways that you can break out of these infinite loops. And don't worry, you can always go back and fix these things. So write your loops, and then if you see that it's going into an infinite loop, just interrupt and fix it and rerun it. Don't be afraid to get it right the first time. Now there is a couple more things within while loops. One is that there is a special statement called break. So what you can do with a break statement is, yes, you have this condition within a while loop, and this condition when the condition becomes false, you will break out of it. But sometimes you may want to, depending on a certain condition, depending on what values you are iterating upon, you may want to decide that, okay, I want to stop the execution of the loop somewhere in between. And that is when you use the if character. That is when you use the break statement. So for instance, here we have I equals 1, result equals 1. And then while I is less than equal to 100, we multiply I with the result. So this statement result star equals I is the same as result equals result star I. Okay. And then we have an if statement here, which checks that if I reaches the value 42, then we say that magic number 42 has been reached, and we are going to stop the execution, and then we are going to break out of the loop. So this break gets executed, and then we exit the loop completely, and then we execute these statements, right? So you can see here that I at the end of the while loop has the value 42, and the result is not nearly as close to the factorial of 100 that we initially had. In fact, it will be 42 factorial exactly. So that is a break statement. And then there is another statement, that is the continue statement. So the continue statement is slightly different from break. What it does is it completely breaks out of the loop. But what the continue statement does is the continue statement. So here let's look at an example. So again, we have I equals 1, result equals 1. And then while I is less than 20, we increment I. So we go from I goes from 1 to 2. And then we check if I is even. So if I is divisible by 2, the remainder of I with 2, if it is 0, then we print that we are skipping I or whatever that number is. And then we have the continue statement. So what the continue statement does is that when this gets executed, anything else, all the remaining statements in the loop are skipped. So this print statement is skipped and this result multiplication statement is skipped. Okay. So let's try it out. Let's just run this. So you can see here we started out with I equals 1 and then we had I equals 2 in the first loop. So we skipped 2 because this if statement was true. And then we did, so there was no multiplication with 2, but then we did multiply with 3. Then we skipped 4, multiplied with 5, skipped 6, multiplied with 7, and so on. And the result that we get back ultimately is the product of all the odd numbers from 1 to 20. Okay, so that's the continue statement. So break and continue are, well, they're not very often used, but they're quite useful sometimes when you are stuck in a tricky loop where you want to somehow have something come out of the loop based on a certain condition. Okay. So those are loops, and I'm just going to run jovian.commit once again, just to save my work. So those are while loops. Another important kind of loop, in fact, something that you will probably be using the most often, is the for loop. Now, just as while loop is used to iterate while a condition is true, the for loop is used to iterate or loop over a sequence. For example, if you want to perform an operation for every element of a list or a tuple or a dictionary or every character in a string, that is when you use a for loop. And they have a very nice, simple, intuitive syntax. So what we say is for value in sequence, for value in sequence. So we have a sequence and then we take, using the in operator, we take one by one each value from the sequence once we put it into this for statement, and then we can execute a bunch of statements repeatedly, a bunch of statements for each value from that sequence. Okay, and it'll become clear with an example. So here we have a list, and the list has Monday, Tuesday, Wednesday, Thursday, Friday. So it has these elements. These are all strings, and we say for day in days. So for day in days. So what happens is that every time for every element, Monday gets put into the variable day, and then you can print day. Then Tuesday gets put into the variable day, and then the statement gets executed. Then Wednesday gets put into the variable day, and then the statement gets executed, and so on. Okay. And you can see here, as you might expect, Monday, Tuesday, Wednesday, Thursday, Friday gets printed. And here are a couple more ways you can try this out. So we can actually loop over a string and we can get back characters from the string. So for every character in the string, we print out the character. So here Monday becomes Monday. We can loop over a tuple or a list. This is more of a list than a tuple. So here we are going to loop over the list, apple, banana, guava, and then we are going to print it out saying here's a fruit. So here's a fruit, apple, banana, and guava. We can loop over a dictionary as well, which is again something that we will do a lot over the course of the next few lectures. So here we have a dictionary, and then we are going to use the name John Doe, sex male, age 32, married. And then when we loop over a dictionary, what we get back is just the keys. We do not get back actual values from the dictionary. So if you want to access the value, so here's what we do, right? So for key in person, and then we are going to print out the key. So the key is going to have the values name, sex, age, etc. And then if you want to get the actual value stored against that key, then you simply pass the key into the dictionary using the indexing operation, right? So the person key, when key is name, will give you the name, and so on. So let's run this. And so you can see here the key is name and the value is John Doe. When the key is sex, the value is male. The key is age, the value is 32. The key is married, the value is true. And that's all it is. If you do want to iterate over actual values, then you can just call the .values method on a dictionary. So person.values will now give you a list of values, and now you see we have just the values. Or if you want to get back both keys and values, then there is also something called .items, and then .items is going to give you both the key and the value. All right. So that's our for loop. With a for loop, we can iterate over a bunch of different containers, but sometimes you might want to iterate over simply a bunch of numbers, right? You might want to run something, you might want to run a loop from, let's say, numbers from 0 to 100 and then perform certain operations using those numbers. And that is where you can use the range operator, the range function. So here are a few examples. So if you just say for I in range 7, so when you say range 7, or any range n, that creates a sequence of numbers from 0 to n minus 1. So range 7 creates a sequence of numbers 0 to 6. You can see that here. If I print it out, that's going to create the range of numbers from 0 to 6. You can also specify a start index and an end index. So what you can do is you can say range of 3 to 10. So what that does is that starts with 3 and then goes all the way up to 10, but not including 10. So that becomes 3, 4, 5, 6, 7, 8, 9. So you can see 3 to 9 get printed here. And finally, you can also give a step. So here we start with 3 and we go all the way not equal to or greater than 14. So we can go all the way up to 13, but we take increments of 4. So we have 3 and then we have 7 and then we have 11 and then 11 plus 4 becomes 15, which is greater than or equal to our end index. So that is not printed, right? So this is pretty useful. A range is pretty useful when you also need access to, let's say you want to go over a list, but you also want to know within the for loop which element in the list you're accessing, right? The index of the element. So that is when a range is useful. That let's say if you're going over a list, here you have the list of days. What you can do is you can create a range with the length of the list. And then you have the index I that goes from 0 to the length of the list minus 1. So 0, 1, 2, 3, 4 are going to be the indexes. So you can then print that the value at a position 0 is Monday and the value at the position 1 is Tuesday, because we are formatting the string and we are putting in I, the value of the index, and then we are getting the element with that index out of the list. All right. So that is the range function. And similar to while loops, for loops also support break and continue statements. So anywhere within a for loop, if you feel like, okay, you should probably end this loop right now because maybe you found what you need of the loop. And similarly, here is the continue statement. So here you can see that beyond Wednesday, we do not process Thursday and Friday. But in the same way, if we were printing things out and we were simply doing a continue, then what happens is that when we reach Wednesday, this statement becomes true. So we print, I don't work on Wednesdays, and then we say continue. So this print statement below gets ignored. All right. So here with continue instead of break, we say today is Monday, today is Tuesday. I don't work on Wednesday, but we still process Thursday and Friday. So those are the break and continue statements. And finally, this is not very common, but sometimes you may want to just create an empty loop, nothing inside a loop. So you just say for day in weekdays and then you say pass. So if you say pass, nothing happens. You simply go over all the elements, but nothing really happens. Now that's it about loops that we'll cover right now. You can nest for and while loops inside each other. So I leave that as an exercise for you to try out. You can nest for loops inside while loops. You can have if conditions inside for loops, inside while loops, and so on. But again, even just as with the conditions, if you nest too many loops, it can become difficult to read and understand. So you may not want to do more than 2 levels of nesting within a loop. Okay, that's all the discussion that we have about variables, data types, and branching and loops. And then I'm going to go back to lesson 2. And now we're going to look at a very interesting topic, something that is at the very core of programming, and that is the idea of functions and scope. Okay, so open up the notebook. Let me just click run on Binder. Wait for that to get started. All right, so let's just go full screen and let us hide the toolbar. So I'm just going to do kernel restart and clear output. Okay. So we've already seen some functions, right? We've seen the print function, we've seen the len function, we've seen the data types related functions, which can convert data types from one type to another. And then we've seen methods as well. But just to recap, a function is basically a reusable set of instructions. That is, there is some logic which you think can be used again and again on different data, or needs to be, you do not want to write the same set of code each time you want to do that, perform that operation. So you convert it into a function, and a function takes one or more inputs, performs certain operations on those inputs, and then often returns an output as well. Okay. And Python provides many built-in functions like print, len, and so on, but you can also define your own functions. So this is a print function, pretty straightforward. We've seen this, but here are the inputs. Today is, and then today, that is an input as well, which becomes Saturday. And then the print function simply performs an operation which is displaying the input on the screen. It does not return anything, okay? Python allows us to define our own functions as well. So what we can do is we can define a function, let's say called say hello. And now the say hello function can print hello there, and the say hello function will print how are you. So it's a pretty straightforward function. The way to do it is def space function name, and then you have these parentheses or these round brackets. Inside it you can put some inputs, but we're not doing that just yet. And don't forget this colon character. And then the body of the function needs to be indented by 4 spaces, just like the body of a for loop, or just like the body of a while loop or an if statement, okay? So that's a function has been defined. But when you define a function, the statements inside the body are not actually executed. And that's why you do not see anything printed here. So once a function is defined, you need to invoke it, or you need to call it. So that's the same thing. You will hear invocation, you will hear function call, you will hear function execution. It all means the same thing. So the way to invoke a function is to call the function name. So just type the function name and then pass these brackets. So an open bracket and close bracket, that is used to invoke the function. And you can provide any inputs here as well, but our function does not take any inputs, so we're not going to do that. And then we just run say hello, and that is going to print out hello there and how are you. Let's try it again. So if I run it again, it once again prints hello there and how are you. And that is really the key benefit, that now I only had to write it once and now I can use it with a single line. I do not need to type out the code again. Okay. But just functions which do not take any inputs are not very interesting. So functions can also accept one or more values as inputs, and sometimes you will see them referred to as arguments or parameters. And there are some technical differences, but ultimately these words are used quite interchangeably. And these, so we'll go with the word arguments because that's the most common thing that you see used. So arguments to a function help us write flexible functions which can perform the same operation but on different values. Okay, so for instance, we'll create a very simple function and then we'll see this function that is already there. So here we say we have a function say hello, and we will let it accept a name, and then we will print hello, and we will do a string formatting and we will pass in the name. Okay, so if we just say hello to John, that says hello John, and say hello to Jane, and that says hello Jane. So just taking that idea forward, here is an example of a function. It's called filter even. What it takes is that it takes a list of numbers, a number list as an input, and then it does certain things and then it returns an output. Okay, so there's an input going on here, and then there's some operations being performed here, and then there is a return statement. So I'll tell you what this operation, what it does, and I'll not go over the code exactly, but what it does is it takes the list of numbers and it only keeps the numbers, it only retains the numbers that are even. All right, so the result list will contain simply the numbers out of list which are divisible by 2. And the way it does it is it loops over the number list and it checks whether that number is divisible by 2 or not. And if the number is divisible, it appends it to result list and then returns the result list. Okay, so let's try it out. So here, and by the way, the return, a function returns, to return a value, you simply say return and then pass the variable or the value that you want to return. And what you can do now is we can invoke filter even with a list of values, and then we can take this output of filter even and put it, so use an assignment operator to assign the output of filter even to the variable even list. All right, so we have we have 1 2 3 4 5 6 7, and then we have the even list. So you can check that now the even list only contains 2 4 and 6. Okay, and now you can take the same filter even function and then you can run it with a different array, let's say 1 3 5 7 9, and this time when we run it we get back the empty array or the empty list, I'm sorry. Okay, so those are functions, and then now we have functions with return values. So the next thing we want to look at is how to write great functions in Python, because as a programmer, you will be and you should be spending most of your time writing and using functions. The more functions you write, the better you get at programming, because you then learn to structure what you need to do into small functions that you can reuse in different ways. Okay. And we are going to explore how to write a great function and using the many features that Python offers. And we'll do this by solving a problem. So let's see. So here is the problem that we'll try and solve. So Radha is planning to buy a house that costs $1.26 million. So $1,260,000. And when you buy a house that's so expensive, you have to probably get a loan. So she's considering two options to finance her purchase. So she has one option, which is to make an immediate down payment of 300,000. So she just pays 300,000 right now and then take a loan, an 8-year loan with an interest rate of 10%. So a loan has a duration. The duration is 8 years. You have to repay it in 8 years. And there is a certain interest that you pay. So there's a 10% per annum interest rates. So I should probably just put in per annum here. Okay, so there is a 10% per annum interest rate. And then there is a 10-year loan, which has an interest rate of 8% per annum. Okay, so she can either take out an 8-year loan for just the remaining amount if she pays 300,000 right now, or she can take out a 10-year loan with an interest rate of 8% for the entire amount. Now, both of these loans have to be paid back in equal monthly installments, also known as EMIs. So now what we want to figure out is which of these two loans is going to have a lower equal monthly installment. Okay, and this is the problem we'll solve, and then we'll build this function step by step. So we'll also see how to build a good function, and we'll use certain features of Python to make it very flexible and powerful. Okay, so the simplest thing that we can do is, since we have to compare EMIs, we need to calculate these EMIs or monthly installments for both of these loans. So it'll be helpful to define a function so that we do not have to type out the same logic for each of these loans. All right. So we're going to define a function called loan EMI. And to start with, we're going to simplify it a lot. We're just going to say that, okay, you just give us the amount and we'll assume that there is no down payment, there is no interest, and the loan has to be paid back in exactly 1 year in monthly installments. Okay. So we simply take the amount and then we divide it by 12, and that gives us the EMI, and then we print out the EMI. Okay. Using the print statement. So our loan EMI function just takes one input. So here we call loan EMI with 1.26 million as the input. So you can write it like this: 1,260,000, or you can also just say 1.26 E6, which makes us 1.26 multiplied by 10 to the power of 6. So that is 1.26 million. Okay. So if you take out the entire amount you want to repay in 12 months, then this is the amount that you need to pay per month. Pretty simple, straightforward. That's fine. So now let's add a second argument. So let's, apart from the amount, let us also include the duration of the loan in months. So after what time are you going to completely repay the loan? So you have the amount and then you have the duration in months. So we put in the duration here, and all we need to do is divide the amount by the duration. And once again, we're just going to return the EMI. Okay. So we've just extended our function a little bit, and step by step, we're going to just make it better. Now, one thing I want to note here before we actually use this function is that you will see that I have actually created a variable called EMI here. Now, where does this variable live? Because if you try to access this variable, let's say I try to access EMI, it says the EMI variable is not defined. And it's not, if I call the function, it will become defined. Let's say if I just call loan EMI with 1.26 E6 and with a duration of 10 years. So that is 10 times 12. So we need the duration in months. So the function has been executed, but even now the EMI variable is not accessible. Not only the EMI variable, but even the amount and the duration. Okay. So even if you try to access these, they are not accessible. And that is because these are all local variables within the function, right? So a function, when you define a function, within the function, there is a scope, and all these variables which are used inside the function are only available within the function, and they are called local variables. So scope is basically the rules that define where a certain variable is visible. So if you have a variable that was defined outside in a separate code cell, that is a global variable. You can access it anywhere in your code. And then if you have a variable that is defined within a function, that is a local variable. Okay. And that's a very useful thing to have, because now you can define, let's say 5, 10, 15, 20, 100 functions. In each of these functions, you can use the same variable names without worrying about what you do with a variable in one function inside a function affecting the value inside another function. So each of these will get initialized from scratch inside the function. So that's just a little note on scope. Okay. So now we can compare a 8-year loan with a 10-year loan. For the 8-year loan, we pass in 8 into 12, those many months. And for the 10-year loan, we pass in 120 months. We still are not considering the down payment. So you can see that the EMI obviously for the 10-year loan will be smaller than that for the 8-year loan, as you might expect. Okay. And now this is great. We can see visually that these values are different, but it would be nice to compare them as numbers. And maybe we want to calculate the difference and so on. And that is where we can actually use a return value. Let's modify our loan EMI function now. And this time what we are going to do is we're going to return the value of the EMI. So we're going to say EMI is amount divided by duration, and then return the EMI as a value, as an output. Now when we call loan EMI on 8 years, we can actually take the output and then put it into an EMI1 variable. And then we can then go for EMI2 and take the value of the 10-year loan and put it into EMI2. So now we get an EMI1 and EMI2, and we can now take a difference of these two. And we can check, okay, there's a difference of $2,000 between the two EMIs. Again, right now we are not considering down payment or interest, but it's a good thing to see how things are evolving. Okay. So next up, let us add the down payment, the immediate down payment, the amount that you're going to pay right now that needs to be deducted, and the rest of the amount is what you need to take the loan for. Now, since the first loan has a down payment, but the second one does not, what we can do is we can make this an optional argument with a default value of 0. So now we still have the amount, we have the duration, but we have the down payment, and the down payment has a value of 0. So now the loan amount becomes amount minus down payment. And now the EMI becomes the loan amount divided by the duration, and then we return the EMI. So here when we have an optional argument, we can invoke it just as a normal argument. So here we say we pass in the loan amount, we pass in the duration, and then we pass in the down payment. That's the first loan, the 8-year loan with a down payment of $300,000. And now we get back $10,000. We get back $10,000 EMI. But on the other hand, here what we have is we've just passed in the loan amount and we just passed in the amount and duration, and we've not passed in a third argument. So when we do not pass it in, Python takes and converts this. Python simply uses a default value, down payment equals 0. So the loan amount simply is the whole amount, and hence you get back the EMI for the second loan. Okay. So optional arguments, very useful to have, makes your functions very flexible and easy to use. Okay. So next, now let's add the interest into the calculation. And this is the part you may have been wondering, how are we going to calculate interest? How are we going to introduce that? And we're just going to use a formula here. And it's not a very difficult formula to derive. You have a little bit of math like arithmetic progressions and such, but I'm not going to go into the derivation of this formula. I have linked to a video if you're really interested in understanding how it works. But the idea here is to get the equal monthly installment, we take the loan amount, which is also called the principal, and then we multiply it with this expression. So we multiply it with the rate, and this rate needs to be the rate of interest per month. So note that the rates that we are given are in per annum. We multiply it with 1 plus r, so that's 1 plus the rate, raised to the number of months, right? The number of periods that we want to talk about. And then we divide the whole thing by 1 plus r to the power n minus 1. Okay. Again, it's just a mathematical formula, and we simply need to convert that into Python code. So let's do that. So now once again, we are going to introduce, we have the amount, we have the duration, we have the rate, and then we have the down payment. Now, one thing to notice here is that all the required arguments in the function, the arguments that have to be specified, have to come before the optional arguments, because what happens is otherwise if you invoke loan EMI with 3 arguments, Python may get confused whether you're trying to refer to the down payment or you're trying to refer to the rate if down payment is before rate. So remember to keep all of your optional arguments at the end of the function definition. So once again, we take the loan amount, that is the amount minus the down payment. Then we have the EMI, which is the loan amount multiplied by the rate multiplied by 1 plus rate raised to the power of duration. And that's why we took the duration in months. And remember, the rate has to be monthly as well. And then we divide the whole thing by 1 plus rate raised to the power duration minus 1. All right. So that's our loan EMI function. And we are getting there. So now we have the down payment, now we have the EMI, now we have the rate of interest, and now we have the duration included as well. So now when we talk about the 8-year loan, we pass in the duration as 8 multiplied by 12. And then we pass in the rate. So the rate was 10% per annum, which is 0.1 and 0.1. So the monthly rate becomes 0.1 divided by 12. So that's what we've put in here. And this was the down payment. And that gives us back what the EMI looks like, around $1,456.7, $14,000 per month. And then similarly for the second option, we simply put in the amount and then the duration and the rate, no down payment, and then we get back the EMI value. Okay. So now this is good. And now we have already answered the question. So we can see that option 1 has the lower EMI. So that's good. Radha can now decide what to do. But if you look at this function call, it's not looking very pretty. It's not easy to tell what are all these numbers that you're putting in here. In fact, it would be really easy to make a mistake here. I could very easily, if I do not remember things correctly, I could just put in this here and then that would still give me a result, but that would be a completely false result, right? This is completely wrong. So the way to avoid that is to use something called named arguments. Okay. So while invoking a function with many arguments, it can get confusing and there can be human errors. So what you can do is you can specify the name of the argument before the actual value that you pass in. So you can say loan EMI, and then I have written out each argument on a separate line, and you can do that. You can split the function invocation into separate lines, but you don't have to. You can write it all on the same line as well, as I've done for the second case. But the key idea here is you can type the name of the argument, then put in an equal to, and then put the value in. So this can be a value, this can be a variable, this can be an expression. Like here, this is an expression, 8 multiplied by 12. Here is the rate, and then here is the down payment. Okay. So that looks much nicer. Now and by the way, when you do that, you can actually change the order of arguments as well, because you're specifying the name. So you can actually put duration before, the amount and so on. So that's the EMI one. So that's about one, you get the same result, no change, even though I changed the order of the arguments. Then we have EMI 2. This is for the loan without the down payment, the 10-year loan, 8% rate of interest. And once again, we get back the same result. Okay. So this is fine. This is good. But if you see this, I don't like this whole 10 characters of 10 digits after the decimal, because normally you're going to pay back whole dollars. So what we might want to do is we might want to round this up to full dollars. In just a second. Yeah, so we might want to round this up to full dollars. And what you can do is you can maybe write a function. You can write a function called round up. Okay. And that takes a number X, let's say, and then try to figure out what you can do here. So try to figure out what you can do here, round it up and return the result. And you can use this function inside the loan EMI function. So functions within functions, using functions within functions is a very powerful technique. You can try this out and it'll be a good exercise. But since this is such a common thing, rounding numbers up and down, Python provides a built-in function for it, except that this built-in function is part of the Python standard library. So because there are a lot of, Python is a general purpose language that is applied to many different use cases in scientific computing, in data analysis, in software development. So it doesn't make sense to just put all these functions into the global namespace, because that is going to just put in tens of thousands of function names into our global namespace, and every time you try to declare a variable, it might collide with a function, or your known function names might collide with functions. So what Python does is it puts them into modules, right? So modules are nothing but files containing Python code. So they can contain variables. So these are files with a .py extension, and then they can contain variables, functions, classes. And what they do is they give you a way of organizing large Python projects into files and folders. And the key benefit that modules offer is namespaces. That is, when you want to use something from a module, and we'll see an example very quickly, you need to first import the module, and then all the methods, all the functions, everything inside a module will have to be accessed using the name of the module. So that makes sure that your global namespace that you're working with does not get affected. And that allows people, like if you have 20 people or 100 people working on a project, everybody can write their own modules, and they can use the same variable names, they can use the same function names, and that will not cause problems when you want to use those modules together. Okay. So here's and by the way, you can write your own modules, but we are going to use some built-in modules from the Python standard library. Okay. So I'm going to import the math module that contains a lot of math related operations. And inside the math module, there is a function called ceil, C-E-I-L, which stands for ceiling, which basically takes a number and then rounds it up. So if I want to know what the ceiling function does, I can simply call help on ceiling. And here it says the ceiling of x as an integral is what it returns. It takes a single value x, and it is the smallest integer that is greater than equal to x. So that's exactly what we want. So now to invoke this function, we say math.ceil, and that rounds up 1.2 to 2. Okay, so that's great. So now let's update our loan EMI function to, it is the same function as before: amount, duration, rate, down payment, get the loan amount minus down payment, calculate the EMI using the formula, and then call math.ceil on EMI, and then store the result back into EMI. So this is just going to do that rounding up. And now if we calculate the EMI, you can see that 14568 is the EMI for the first option, and 1515288 for the second option. So we can compare these EMIs or equal monthly installments now, and then we can print a nice message which Radha can view. So you can imagine you're building this system where people can put in a bunch of loan options, and then they get back whichever is the best, or whichever has the lowest EMI, or whatever they want to optimize for. And yeah, and that's it. So that's one way of just using functions, and we've built this function step by step, and we've made it better over time to answer this problem. Okay, but apart from just answering this problem, what we have achieved here is actually we've created a fairly generic function that can be used to solve many other similar problems. And now we do not have to think of that entire logic. Like we do not need to remember the formula, we do not need to figure out how to round things up, and so on. So let's try a couple more problems, and let's see how easily we can solve them using these functions. So here Sean is currently paying back a home loan for a house he bought a few years ago. So Sean has a loan of $800,000. The loan has a duration. The duration was a 6-year duration, and the loan has a down payment of 25% of the cost. So which is 200,000, right? So there's a down payment of 200,000 on an $800,000 loan, sorry, on an $800,000 house. So the rest of the amount is on a 6-year loan with an interest rate of 7% per annum. Okay. Now that's one loan that Sean has. Another option is another thing that Sean is doing is Sean is now buying a car worth $60,000, and he is going to finance this car using a 1-year loan with an interest rate of 12% per annum. Okay. And both loans are to be paid back in EMIs. So what is the total monthly payment that Sean has to make? Okay. Looks a little bit complicated, but if we break it down, there are just 2 loans going on here. So here is the first loan. Cost of house is such and such. The 6 years is the duration, 7% is the rate of interest, and 25% of 800,000 is the down payment. We simply put it into the loan EMI function, and we get back the EMI of the house as $10,230. Here is the second loan. So we have a $60,000 loan. The duration of the loan is 12 months. So 1 times 12. And the rate of the loan is 12% per annum. So we need to divide it by 12 to get the monthly rate. And then we put it into loan EMI. And that's it. That we get back the EMI for the car is $5,000 per month. And now we can display the total EMI that Sean makes a total monthly payment of the EMI of the house plus the EMI of the car towards loan repayments. Okay. So yeah, that's great. We've solved another problem using just these 1, 2, 3, 4, 5. This is technically just one line of code split across multiple lines. So 5 lines of code for the first loan and 4 or 5 lines of code for the second loan, and the problem is solved. Okay, let's try one more. This one is a little more interesting. So here what we have is, if you borrow $100,000 and you are on a 10-year loan and you have a rate of interest of 9% per annum. So what is the total amount that you end up paying as the interest? So over and above the principal, the $100,000, what is the additional amount that you end up paying? So there's one simple way to do this. And what we can do is we can assume that there are 2 loans, one with interest and one without interest. Okay. So here's the loan with interest. It has the value amount of 100,000. It has a duration of 10 years and it has a rate of interest 9% per annum. So that gives us 1267 is the EMI with interest. Okay. Now let's suppose that there was no interest on this. So what we can do is we can simply get the EMI for the loan without interest. And then if we subtract the 2 EMIs, we get to know how much interest we are paying per month. And then we simply take that over the entire duration. So that gives us the total interest, right? So that's one way of solving it. There are other ways too. So let's put in the amount 100,000. Let's put in the duration and let us put in the rate of interest as 0. Oops, but something seems to have gone wrong here. And let's see what went wrong. Now this will happen to you a lot before you get better. And even after 12 years of doing Python, I still get exceptions all the time. So don't worry if something goes wrong. Just where you want to start is look at the last line. So it seems like this is a 0 division error. So what happens is whenever you try something that causes something to break while the code is executing, Python throws an exception. By throws, what it means is wherever the error occurred, it is going to stop the execution of the program there. And then it is going to just print out this error message for you. So it seems like there was a 0 division error. We were trying to divide by 0. And float division is simply the normal single division. So we were trying to divide by 0. Where were we trying to divide by 0? That is where you now go up and see that, okay, within the loan EMI function, if you check the third line, this is where this arrow points. So in this formula, it seems like we are dividing by 0. And now you can probably guess, because the rate is 0, 1 plus rate becomes 0. And because 1 plus rate becomes 0, 1 plus rate becomes 1. So 1 plus rate to the power of duration becomes 1. And 1 minus 1 becomes 0. So this entire denominator is now 0. And that's a problem because now dividing by 0 is not defined. And so the loan EMI returns an error. And that is why the EMI without interest, the code execution stops at this point and nothing gets printed. Okay. What do we do? So when an exception is thrown, when an exception is thrown by Python, you have a chance to actually handle that exception. And an exception, the way to handle it is using a try statement. Okay, so here's a small example. So what you do is you say try whenever you're writing some code which you think might cause certain errors. So you say try, and then here I'm going to print a statement saying computing the result, and then I'm going to divide 5 by 0. Bad idea. It's going to break here, and then I'm going to just say computation was completed successfully. So now since I know that this might break, because maybe 0 came in as a function argument or something like in the previous function. So when I know that this is going to break, I can put in an except statement and put in the type of error that I might expect. So the except statement and then the type of error is a 0 division error. So here what it is saying that if you get a 0 division error while executing this code, then do this. So what we do is we print that we failed to compute the result because you were trying to divide by 0. And then we set the result to none. And then we simply print the result out. Okay. So you can see here, it says now computing the result. It tries to compute the result and it blows up. Now the print statement, this one does not get executed because we've broken out of the execution, but the except handles the error. And then these two statements get executed. So we say that you failed to compute the result and result has the value none. This on the other hand, if I were doing 5 divided by 2, so now this runs normally. So we never come into this error case and we simply print out that the computation was completed successfully and the result has the value 2.5. Okay. And this is what you can do. You can actually have multiple except statements if you know that there can be multiple types of errors or exceptions that can be thrown. And Python has a lot of different exceptions. So you can actually check out, I've pointed to a link here. You can learn about more exceptions in Python. But what we want to do is we want to just take the loan EMI and add the try except inside it. Okay. So what we want to do is we want to try to calculate the EMI for the loan using the formula that we had. But if that returns an error, especially if it leads to a zero division error, then we can say that if the zero division error will occur only when the rate is zero. And when the rate is zero, you can simply divide the loan amount by the duration. So then we simply divide the loan amount by the duration. And that handles the error for us. Then we again round it up and then we return it. Okay, so that's great. So now we can use this updated loan EMI function. Once again, the question was you borrowed $100,000 using a 10-year loan with a rate of interest of 9%. What is the total amount you end up paying? So we calculate the EMI with interest and then we calculate the EMI without interest. And this time it works even with the rate of 0. And then we can see that, okay, there's a difference, a significant difference with and without the EMI. So we do the EMI with interest minus the EMI without interest. And then we multiply it with the duration of the loan, which is about 10 years, right? So 10 times 12, those many months. So that gives us the total interest that is paid. And now we can display that the total interest paid is 51,960. Okay. And that's a good thing to know whenever you're taking a loan. What is the total interest you're going to end up paying? And are you okay with that versus just paying it? All right. So one last thing now, we can also add some documentation within our function using what is called a doc string. So this is what we saw the help method that we used with the seal math.seal. Okay. Now, how do you, if you want to add your own, if you want to add explanations within your own functions, and you should do that, the way to do that is to include a string as the first statement within a function. So here I'm using a multi-line string. So here I'm going to say that it calculates the equal monthly installment for a loan. So that is a description of the function. And by the way, you can just write that and that should be good enough too for a lot of things. So you do not need this necessarily. But anyway, I'm going to use this too. So I put in one line about the function, then I am just giving a space just to make it a little clearer. And then I'm going to just describe the arguments as well, that the amount is the total amount to be spent. So here I might want to specify that do not this should be the loan amount plus down payment that you're putting in. Then the duration is simply the duration of the loan, but in months. So that's an important detail to give. And then the rate is the rate of interest, but it's monthly. And then finally, the down payment is an optional argument. It is an optional initial payment deducted from the overall amount. Okay. So this is how you, this is how you document a string, document a function. That is, explain what it does for the people who are going to use this function. And the rest of the body of the function is the same, right? So the rest of the things just go in the body. Now, when you have the documentation, you can simply call the help function. And you can see that the same documentation gets printed. So this is very useful. It will be useful for you. It will be useful for others using your function. It will be useful for people reading your notebook as well. So whenever possible, write documentation for your functions. Okay. And now we can just save and upload our notebook. So again, since this is running on Binder, I don't want to lose my work. So I'll just grab my API key here and put it in. And as you keep committing notebooks to your profile, they will get added up here. So you can see here, I have a bunch of these notebooks and you can always come back and run any of these. And then if you commit again, then they will get updated. So each of these notebooks, you can see how many versions they have and so on. And you can also share these notebook links online with your friends. If you want to just say, give a quick tutorial or answer a question specifically, even on the forum, if you want to answer a question and you can quickly create a notebook to do it. So you just do new notebook, create a new notebook, run it on Binder, type out the solution and then commit it back. So once you get a notebook on Jovian, you can commit it back and then you can simply share the result on the forum. Another thing to do is if you're getting stuck at some point, then just commit your notebook and take the notebook link and post that on the forum saying that this is what I've tried and this is how I failed. Unless you describe what you have tried, it's very hard for people to help you out. Generic questions like, I'm not able to solve this problem is not very helpful. because people will not be able to help you. So the best way to get help is to offer as much description about what you've tried. And the best way to do that is to share the actual notebook that you have been using, maybe just the piece of code that you are working with. Okay. So that's about functions, and there's a lot more to functions. So just a quick review of what we've covered, and I'll talk about an exercise for you. So we've talked about creating and using functions, and we've talked about creating functions with one or more arguments. And we've talked about local variables in scope and returning values using return, using default arguments, using named arguments while invoking a function, importing modules and using the library functions, reusing and improving functions to handle new use cases. So what we saw was we kept improving the loan EMI function over time. And this is something that you should do a lot, keep improving your functions. And we handled exceptions using try except. And then finally, we documented functions using docstring. So that's a lot of ground that we've covered in just 45 minutes. So I hope you've been able to follow. And if not, you have this notebook. So experiment with the notebook. So what you should be doing now, after the lecture, you should be going file, new notebook, Python 3. Take this notebook, put it on one half of the screen. Take this other notebook, the existing notebook, and put it on the other half of the screen. Okay, and now what you should be doing is you should be actually typing out all of these things by yourself. So for instance, the loan EMI function, instead of just looking at the function and trying to understand it, you should be defining, you should be saying def loan EMI. And I'm just going to take the amount right now and return amount divided by 12. And then just try it out. Just try to break things. Just say, okay, what happens if I pass in loan EMI? I take a loan of $100. Okay, that seems to be the EMI. Now here you might get certain ideas. What if I pass in 2 arguments? What if I call it without any arguments? If you call it without any arguments, it says, oops. It's going to tell you that the loan EMI has one positional argument, amount, which you have not passed. You can try calling it with multiple arguments. That's going to give an error. So all of these questions that you might have, the more curious you are, the more you break things, the more you learn. And the best way to do that is to just type out the code yourself, because as you're typing, you will wonder, what can I change here? What can I break here? And the more you explore, the more you learn about Python, the better a programmer you will become. Okay. All right. So now we have an exercise for you. This is not an assignment or anything. This is just for you to understand. So here you're planning a leisure trip and you need to decide which city do you want to visit. So you've shortlisted 4 cities and you've identified what is the return flight cost and what is the hotel cost per day and what is the weekly car rental. Cars have to be rented for full weeks. So even if you want to use a car for 2 days, you still have to pay for the week, and hotels are rented per day or per night. And then you have the return flight, which is just a one-time cost. Okay. So using this data, and this is a real life example of, again, some analysis that you might have to do in real life. So using this data, if you're planning a 1 week long trip, which city should you visit to spend the least amount of money? Okay, so that's one question you can answer. And how does that answer change if you change the duration of the trip from 1 week to 4 days, or maybe 10 days or 2 weeks? So it's a good thing to explore all these things. If your total budget is $1,000, then which city should you visit to maximize the duration of your trip? Or maybe you actually do not have a lot of time, but you'd have a good budget. So which city should you visit if you want to minimize the duration of your trip? So these things are something that you can figure out. And then you can change the budget, try $600, try $2,000, try $1,500, and all of these things. And to do this, it will be very useful for you to define a function like cost of trip, which will take in all the relevant inputs like the flight cost, hotel rate, car rental rate, and duration. And it will calculate the duration of the trip. All right. And calculate the cost of the trip. And then you can use that to answer all of these questions or any other questions that you may have. So do try this out. This is going to be a good exercise on functions. And what we will do next time is we will continue working on functions, but we will also see how to work with files. So we will process some files, and then we will perform certain data analysis and certain operations from data read from these files. What should you do next? Try out the notebooks yourself. As I said, open up side by side and then type out the code. Start working on the assignment. So assignment 1, once again, just to repeat, you go on the lecture page 0topandas.com, click open here on assignment 1, and run the notebook, make some changes, commit it back to Jovian, take the Jovian link and submit it here. So we'll take your last submission and evaluate it, and based on that we'll give you a pass or fail grade, and that will be done. Another very important thing to really learn things well is to ask and answer questions on the forum. So I would suggest make it a point to answer questions on the lecture forum thread, which you can access from here. So here's a discussion forum thread, or in general from the course page, you can just find the course community discussion forum. So you can click through to that link as well, and you can find all the discussions that are happening, lecture 2, assignment 1, lecture 1, and so on. And just try and at least ask one question per week and answer maybe 2 or 3 questions per week. The more you answer, the better your understanding becomes as well. So please do that. A lot of people are helping each other. So I just want to give a shout out to everybody who has been helping out. Talk to people on the forum, ask questions, try your own ideas, try to break the code. The more time you spend on this, the better you will get at it. So I will see you on the forums.